here is a question, and the question is, if a universally quantified statement is false, okay, does that mean that existentially quantified statement is always true? Okay? So what I'm saying is that, let's say for all x, p of x is false. Okay, this statement is not true. Does it mean that this thing mean that if I replace universal quantifier with the existential quantifier, would this be true?
No, sir.
No, sir.
It depends on the domain.
Sir,
Yeah,
just
it does not.
I'm not sure. No, sir.
Yeah, we can't imply this, right? Because so it's possible that the statement is false for everything in the domain. Okay, assume करें कि मैं ये कहता हूँ कि x square is less than x for all x. Okay, so here's the thing. For all x ups, अगर आपके पास एक simple statement है तो उसके आप बाद भी लिख सकते हैं. Okay, so this is another way to write it. But let me not confuse you at that point. So let's say this is it. This is my statement where x is larger than 1. Okay. So for this domain, the statement is true, false for every possible x. Okay. When x is more than 1, we know that x squared is more than x. Okay. Which means that this statement is false for because this is false because I can find an example, right? But this thing, to say that there exists x squared where x is less than x, is also false. Okay? There does not exist such thing. But proving this thing is trickier. Okay? In any case, we know that this does not imply this.
Sir?
Yeah.
Sir, ये चीज़ समझ नहीं आई, एक दफ़ा दोबारा प्लीज़ बता दें.
Yeah, sure. Okay. So the question was, let's say you have a statement which is, जिसको अगर मैं universally quantify करूँ, तो it becomes false. Okay. Does this mean that if I existentially quantify it, it becomes true? The statement is, the answer is no, that's not true, because it's possible that the statement is false for everything in the domain. Okay, जो भी मेरी domain है. Let's say this is my domain, this is our values in the domain. Okay, and it's possible that the statement is p of x is false for everyone. If p of x is false for everything here, so here universal quantifier will be false and the existential quantifier will also be false. Okay, so the answer to this question is no. Okay, not necessarily.
So basically, it depends upon the domain.
Yes, it depends on the domain. Yeah, bilkul. Okay, here's an example. Let p of x be a statement which says that x is a prime number, and let O of x be a proposition, a predicate, sorry, which says that x is an odd integer. Okay, given these two, given the proposition, okay, so we make a proposition from this, which says that for all x, px, if p of px, then ox. So what it's saying is that for an integer, if it's a prime number, then it's an odd number. This is what this statement is saying. I'm saying that for all x, px implies ox. Okay, which says that for any integer, if it's a prime number, then it must be an odd number. Okay, this is a proposition, and is it true?
No.
It's not. It's
For
not.
all के लिए नहीं है.
Yeah. For all के लिए नहीं है, because we can find an example, which is written over here. When x is equal to 2, it's a prime integer, and it's not an odd number. Okay? Which means the statement is false.
So can you repeat this again? My internet was lagging a bit. I missed this example.
Okay, sure. So we have an example in which we are given two predicates. One predicate says that x is a prime number. The second predicate says that x is an odd number. We construct a proposition which says that for all x, px implies ox. Is this true or is it false? And what does it mean? What it means is that is every prime number an integer, an odd integer? Okay, and we saw that this is false because we can find one example, which is this x is equal to 2, where this is false, right? Where p of x is true and o of x is false. Okay, so this universally quantified proposition is wrong, false.
Okay, sir.
All right, so we have the same example, but instead of doing a universal quantifier, we are doing an existential quantifier. Okay, when we do an existential quantification of this statement, this says that there exist. Sorry, the statement हमने थोड़ी सी change किया. Okay, so the statement is there exists x such that p of x and not o of x. Can anyone tell me what does this statement mean?
There exists an integer that is prime and it is not an odd number.
Yes, perfect, awesome. This is what it's saying. Just start reading from here. It says that there exists an integer x. हमने कहा है कि उसकी जो domain है वो integers है. So this must be a prime number. Okay, this is what it's saying. X is integer, which is a prime number, and it's not an odd integer. This is what a statement is saying. Does there exist? So the question is, does there exist an x which is prime and it's not odd?
2.
And it's true,
True.
right? It's true, right? Because it does, and this is that guy, x is equal to 2. Great. To prove an existential statement is almost same as proving a universal statement false. Okay? इसके लिए आपको सिर्फ और सिर्फ एक example चाहिए होती है. You need to find one value in the domain of your variable for which the statement is true. So it's slightly easier to at least state. Okay? You only need one x जिसके लिए statement true. Okay, so here's a thing about precedence of operators. When you use existential or universal quantifier like this, what does it mean? Okay, when you write for all x, px, and qx, what does it mean? Is this a proposition or is this predicate?
Sir?
Yeah.
Sir, can you please explain the last example again?
Okay, sure. So here's the thing. The statement says that does there exist an x such that it's a prime number and it's not an odd number. Okay, what do you think? Does there exist a prime number which is not odd?
No.
Yes, no?
No.
No?
No.
Well, it does, right? It's written right here. When you pick x to be equal to 2, you get a prime number and it's not odd. Do you agree?
Yes. Yes.
Okay, good. So we found an example, which means that this statement is true. Okay?
So ये existential वाली example है ना क्या इसके अंदर हम existential या तो हम universally use करके prove कर सकते हैं या existentially ये दो ways है ना हमारे पास.
True. So which one is this?
Existential.
How do you know this?
Because universal में हम एक चीज को false prove कर रहे होते हैं.
No. How do you know that this
Proposition only,
proposition is an existential quantified proposition? Is there something in the statement which says that this is existential?
तो वो इस sign से मैंने लगाया था कि given the
Perfect.
proposition
Yeah,
के
this
बाद.
is the sign for existential. Na? ये sign यहाँ पे
Yes.
लगा है. This sign says that this is an existential statement,
Yes.
right?
जी.
Awesome. Good. Okay. So
जी sir.
yeah. So we were talking about the precedence, and the question is, if I write for all x, px, and qx, what does it mean? What it means is that this quantifier is only used for the exact next statement. So for all x is only associated with p of x. It's not associated with q of x. Okay. To associate it with q of x, you will have to use parentheses. Okay. So this thing means this part, which is for all x vx, and that's the end of the quantifier, and qx. Okay. It does not mean that x is for all x is quantifying the whole px and qx. Okay, it's just quantifying px, which means that this is not a proposition. This is still a predicate. Okay, because there are still variables here, okay, which are not quantified, which means that this is not a statement key. You can't find the truth value of the statement.
एक्सक्यूज मी सर, इसमें अगर हम डोमेन मेंशन कर दें तो फिर ये प्रोपोजिशन बनेगी?
No. Domain is necessary both for proposition and predicate. तो वो predicate के लिए आपको देनी पड़ेगी. This is still a predicate. Okay? It will become a proposition when I quantify this x. ये q के x को when मैं quantify कर दूँ तो फिर this becomes a proposition. Okay? Domain तो आपको हर सूरत में predicate के लिए बतानी पड़ेगी. Okay? All right. So
सर एक दफा ये दोबारा बता देंगे जरा?
All right, guys, I'm repeating things a lot. Okay, so the thing is, if you miss something because your internet is slow or something, so please don't ask me to repeat it, because we need to cover a lot of content, and we are recording this, right? You can go back to the video, and you can definitely come back to us. Okay, so don't be annoyed by it or something. Okay, I'm sorry, but we need to cover a lot of content. Okay. So over here, all I'm saying is that जो precedence है ना, you use and से ज़्यादा precedence है for all operator की. इसी तरह जो existential operator है उसकी precedence ज़्यादा है and से, which means you apply this operator first, which means that you resolve this and then you resolve the second part of the statement, okay? Which is this part. Okay? So for all x is only used for the immediate next statement. जो कि यहाँ पे p of x है. It's not used for q of x, which means that this is a predicate. It's not a proposition.
Okay,
All right.
thank you, sir.
और की एंड से ज़्यादा प्रेफरेंस
और की एंड से ज़्यादा, एंड की हम नॉर्मली कहते हैं कि ज़्यादा है, लेकिन नॉर्मली और एंड का इस तरह होता नहीं है कि कोई फ़र्क पड़े उनकी प्रेसिडेंस.
लाइक प्लस माइनस सही.
Alright, so there are a couple of variables, जैसे यहाँ पे हम ऊपर वाली स्टेटमेंट में देखे थे, इनको हम फ्री वेरिएबल्स और बाउंड वेरिएबल्स कहते हैं. एक वेरिएबल जिसको हमने क्वांटिफाई कर दिया है, ये बाइंड हो गया, इसको हम बाउंड वेरिएबल कहते हैं. एक वेरिएबल जिसको क्वांटिफाई नहीं किया हमने अभी, दिस इज अ फ्री वेरिएबल. So these are two types of variables. And then for each quantifier we have a scope, which is as long as this quantification is applied. So for example, all I wanted to say here is, for this statement, the scope of this quantification is p of x. This is the scope. Okay, it does not pass to the second part of the statement. So you have these three things: free variables, bound variables, and the scope of the thing. And important point to note is that a proposition does not contain any free variables. Okay. If your statement has become a proposition, it will not have any free variables. All the variables in your proposition must be bound. This, as I said, is not a proposition, the top one. Okay, because this is a free variable. Okay, it's not bound. This, on the other hand, is a proposition because I have used parentheses here, which means that both of these variables are now bound by this quantification. We can also apply the De Morgan's laws and other laws on the quantification as well, as we did on the and or operators. So, क्या?
सर जो proposition में free variables नहीं होते?
No.
ठीक हो गया, thank you sir.
Okay, so we can apply De Morgan's laws as we can other laws, right? So when I say that for all x p of x, the negation of this thing is that I convert the universal quantifier to the existential quantifier, and every and your statement becomes negated. Okay? So not for all x p of x becomes there exists x or not p of x. Okay? So almost the same जो हमने पहले किया था, and it's obvious from this equivalent statement जो हमने last time देखी थी. So if I write not x for all x p of x, you get a not with every statement जो कि यहाँ पे आपको बनी हुई है. Okay? So there not p of x1 and not p of, or. Okay? So जो आपका and है वो convert हो जाएगा or में, and every statement will be negated. Right? And so it becomes there exists x not p of x. It looks sort of complex. You'll look at it and you'll see this is exactly the same De Morgan's law जो हमने AND operator पे apply किया था. Right? Remember जब हमने ये कहा था कि not a and b becomes not a or not b. This is exactly the same thing. I have more than one variables. They are compound by an AND operator. I'm negating them. All of them become negated, okay? And the AND operator becomes an OR operator. Sort of a justification of how we apply De Morgan's law on the quantifying variables. Similarly, not there exists x, p of x becomes quantifier आपका change हो जाएगा into there for all of them, for all x, and your predicate becomes negated. ये आपके पास negated हो गया. All right, you can actually nest quantifiers as well. You can have more than one variable in your statement, and you can write for all x there exists y p of x. Similarly, you can write for all x for all y, p of xy. Okay, you can write this, and you can write there exists x, y, p of xy. So you can have more than one variables. So you can nest them. Okay. Look at this statement. The first one, for all x, there exists y, L of xy. Which one of them are bound variables and which one are the free variables? X and y are bound.
Both are bound.
Okay. Anyone contradicts this?
Y is bound.
X bound नहीं है.
No, sir. Both are
Both are
bound
free,
because
sir.
they're both quantified.
Both are bound.
So, yeah, I think most of you are right. This is, as I said, इसकी precedence सबसे ज़्यादा है there exist की, okay? There exist इसके ऊपर apply होगा, okay? और ये y bound हो जाएगा. लेकिन जब आपके पास there exist apply हो गया है, उसके बाद now you are going to apply for all x, and जो कुछ remaining है उसमें x भी bound हो जाएगा, okay? So your x and y both are bound in this case. There are no free variables. Yeah. How about the second statement? For all x, L of xy.
Y is free.
X is bound, Y is free.
X is bound.
Yeah, good, awesome. How about this? For all x, there exists y, L of xy, z.
Z is
are
free.
bound.
X,
Z is free.
Y, and
X
Z are bound.
and Y are
Yeah.
bound. Z is not.
Perfect. Here we go. X, y is bound and z is free.